Hi friends, so time required to heat a particular mass. How to find that? Let me arrive to that equation. We are assuming that this is a vessel. Okay, it can be decent. Okay, it can be conical also. Okay, now let's say this is a jacket. Now you are taking some mass here. Let us say this is the mass. Let's say M is the mass. Okay, now you want to heat a mass. So you will supply some heat from here in the jacket, and you will remove the heat from like steam. Condensate will be here. Obviously, condensate will be at the bottom of this. Now, if you want to heat this mass, then you have to multiply this mass with Cp. Why Cp? To heat 1 kg of material to 1 degree centigrade, what is the heat required? So that is the kilocal per kg degree centigrade. This is a kg, okay? Now into is 30 degrees centigrade. Now you are heating at 80 degrees centigrade. So basically what you are doing, you are increasing the temperature. Now how you are increasing the temperature? You are increasing the temperature step by step. So you have to take dt. Okay? This dt. Now divide it with dt. So don't confuse it with delta t. Okay, this can happen only for the differences like t2 minus t1, something like 80 minus 30 degrees centigrade. But for in this case, as you are increasing the temperature equal to q. Now the heat supply, how you will supply the heat transfer? So you have to take the heat constant. So you have to equate with u. U is the overall heat transfer coefficient, that is kilocal per meter square over degree centigrade. Okay, this is the unit. Now as you are supplying heat inside this jacket, so how much surface area you have to consider? The surface area, because the steam is not going to touch this point, it will touch this much point. So you have to extract the surface area from this. So this is the surface area. Okay, now this is a meter square. Now, so let us do this. Take this whole from here, and this dt you can take it there. So what dt equals to mcp upon uas dt upon ts minus t. Okay, now t is any temperature at any given point of time. Okay, now to remove this differentiation, you have to do integration of this both the sides. So this is a t. So t initial, t final, and here time equal to 0, t equal to t. This is the completion time. Now this is the integration. Now if you want to remove this integration, then you have to apply the natural logarithm at both sides. So if you apply that thing, then because this is 0, so it will become t only. mcp upon u as, I hope this is visible, and for this ln t final minus t initial upon ts minus t. Okay, so this is the equation you have to use to find the time required to heat this particular mass from, let's say, T initial to final temperature. It in a better way. So this is becoming Ts minus T. So this is the equation number 1. Now let me tell you guys that this is the equation for the steady state flow. But I hope that up to this you are understanding this concept.